Lesson 4. Optical Technology. Reading Guide. Key Concepts. Essential Questions. What do devices such as telescopes, microscopes, and cameras have in common? What is laser light, and how is it used? How do optical fibers work, and how are they used? Vocabulary. Optical device. Refracting telescope. Reflecting telescope. Microscope. Laser. Hologram. Inquiry. How does light do that? A laser show is a spectacular sight as the lights streak through the air. The lights in your home and school fill a room with brightness, but not the lights of a laser. How do laser lights travel in such a straight line? What makes them different from other lights? Optical devices that magnify. Do you wear sunglasses or contact lenses? Have you ever watched an animal through binoculars or looked at a planet through a telescope? If you answered yes to any of these questions, you have used an optical device. Any instrument or object used to produce or control light is an optical device. Some optical devices use lenses to help you see small or distant objects. Telescopes. Hundreds of years ago, people could not see details of the moon, such as those shown in Figure 25. However, by using telescopes, people have learned about objects in space. Telescopes are optical devices that produce magnified images of distant objects. A telescope uses a lens or a concave mirror to gather light. You might have used a small telescope to observe the moon or planets, but some telescopes are much larger. The largest optical telescope in the United States has a mirror that is 10 meters across. This enormous size means that the telescope can gather more light from a distant object than your eye can. The Hubble Space Telescope orbits about 600 kilometers above Earth. It has a clearer view because it is above Earth's atmosphere. Astronomers use it to see objects billions of light years away. Refracting Telescope. A telescope that uses lenses to gather and focus light from distant objects is a refracting telescope. The convex lens that gathers light is called the objective. As shown on the left in Figure 26, light rays that pass through the objective converge and form a real image. The convex lens that a viewer looks through is called the eyepiece. This lens magnifies the image. Recall that refraction differs slightly for different wavelengths of light. Eyepieces often include multiple lenses with different focal lengths so that all wavelengths of light focus clearly. Reflecting Telescope. A telescope that uses a mirror to gather and focus light from distant objects is a reflecting telescope. A simple reflecting telescope is shown on the right in Figure 26. Light enters the tube and reflects off a concave mirror at the far end. The light begins to converge, but before it converges completely, it reflects off a plane mirror toward the eyepiece. A real image forms, and the eyepiece lens magnifies the image. Light microscopes. Telescopes are useful for observing faraway objects, but to observe tiny objects up close, you need a different instrument. A microscope is an optical device that forms magnified images of very small, close objects. A microscope works like a refracting telescope, but its lenses have shorter focal lengths. As shown in Figure 27, light from a mirror or a light source near the microscope's base passes through a thin sample of an organism or object. The light then travels through a convex lens, called an objective, that focuses it. The eyepiece magnifies the image. Microscopes often have several objective lenses with different focal lengths for different magnifications. Key concept check. How are refracting telescopes and microscopes alike. Cameras. Cameras come in many different designs that use lenses to focus images. The design of a typical digital camera is illustrated in Figure 28. Suppose you want to take a photo of your friend on a skateboard. Light reflects off your friend and enters the camera. The light passes through a convex lens or, more often, a lens system. A shutter normally blocks light from entering the camera. However, pressing a button briefly opens the shutter. Light enters and is detected by an electronic sensor in the back of the camera. Recall that a convex lens is a converging lens. Inside the camera, a lens or system of lenses converges the light rays toward the sensor. The boy you photograph is farther away from the lens than the focal point. For a convex lens, this means the image produced is real, inverted, and smaller than the object. Notice in the figure that this is the type of image that appears on the electronic sensor. With some cameras, you can zoom or move the lenses and increase the size of an image. Zooming changes the lens's focal lengths. This means a camera can take enlarged images of distant or close objects. Key concept check. What does a camera have in common with a telescope and a microscope? Lasers. Some lasers are gentle enough to operate on the human eye, but some are powerful enough to cut through steel. A laser is an optical device that produces a narrow beam of coherent light. Recall that light from a luminous source, such as a light bulb, has many wavelengths and spreads out in all directions. Coherent light is different. The light waves of coherent light all have the same wavelength and travel together. The beam is narrow because the waves do not spread apart, unlike light from other sources. Also, the intensity of laser light does not decrease quickly as it moves away from its source. The word laser stands for light amplification through stimulated emission of radiation. One type of laser is shown in Figure 29. An energy source causes atoms of a material in the laser to emit light. This is the stimulated emission. This light travels back and forth within a tube, causing other atoms to emit similar waves. In this way, the light intensity increases. This is the light amplification. Key concept check. What is laser light? Holograms. Perhaps you've seen images on a book cover or on a credit card that seem to float in space. You can see different sides of the object just as you would with a real object. A hologram is a three-dimensional photograph of an object. Figure 31 shows how one type of hologram forms. First, laser light splits into two beams. One beam passes through a convex lens, then reflects from the object onto photographic film. The other beam passes through a convex lens and then travels to the film. The combined light from the two beams produces a pattern on the film that shows both the brightness of light and its direction. The pattern appears as swirls, but when a laser shines on the film, a holographic image appears. Some paper bills and credit cards have a different type of hologram printed on them to prevent counterfeiting. The holograms are made with lasers but can be viewed under regular light. Other uses of lasers are shown in Figure 32. Key concept check. What are some ways lasers are used? Optical fibers. Almost every time you make a phone call, use a computer, or watch a television show, you are using light technology. The electronic signals for these devices travel at least part of the way through optical fibers. An optical fiber is a thin strand of glass or plastic that can transmit a beam of light over long distances. Total internal reflection. Just as water moves through a pipe, light moves through an optical fiber. Figure 33 shows how this happens. A core material surrounded by another material, called the cladding, makes up an optical fiber. As light moves through the core, it strikes the cladding at an angle greater than a certain angle and reflects back into the core. This process is called total internal reflection. Because light stays in the core, a fiber can carry light signals long distances without losing strength. Uses of optical fibers. Phone conversations, computer data, and TV signals travel as pulses of light through optical fibers. Using different wavelengths of light, one fiber can carry thousands of phone conversations at a time. Optical fibers also have medical uses, such as providing light for a physician to perform surgery through a small incision in the body. Key concept check. How do optical fibers work, and how are they used? Relating optical technology. Each of the optical devices that you have read about uses lenses or mirrors to produce or control light. Telescopes and light microscopes produce magnified images. Cameras use lenses to focus light on an image sensor. Lasers produce coherent light. Optical fibers are also a type of optical device because they transmit and reflect light.